Good afternoon, everyone. Today, I'd like to introduce this PT500 multi-stage gearbox fault simulation test rig. It mainly consists of a three-phase asynchronous drive motor, a coupling, double support bearings, a dynamic balancing rotor disc, a bearing radial loading unit, a two-stage parallel gearbox, a planetary gearbox, a magnetic particle load, a brake, a cooling fan, and a frequency converter, as well as an oil circulation system. The front panel of the device features some control and display instruments. First is the radial load display gauge once the load is applied. The radial load will be shown here. The power supply is 220 volts AC, and this is the power input port. This is the power switch, and this is the oil pump start-stop switch. Here's the course adjustment knob for speed, the fine-tuning knob for precise control, and the emergency stop button. The speed display on the input side and output terminals. The speed display meter on the output side, the output speed, and the BNC output terminals. The magnetic particle load torque adjuster, and over here is the load switch. This is the communication interface for the frequency converter. Now, let's start the equipment. We'll demonstrate how it operates step by step. Turn on the main power switch, and all the meters will activate. Gently rotate the course adjustment knob, and the device will start up. This shows the rotation speed of the motor's input shaft, while this displays the output shaft speed of the gearbox. We can turn on this load switch and adjust the current to vary the torque load of the magnetic powder. When under load, the gearbox produces a duller sound, which is a common phenomenon in mechanical operations, allowing simulation of vibration and noise conditions under both loaded and unloaded states. This test rig mainly supports shaft misalignment, which is crucial for related mechanical operations. Rotor dynamic imbalance, loose foundation, shaft friction, and bearing testing, with 5 faulty bearing options like inner race, outer race, rolling element, and cage. It also performs comprehensive gear fault tests, including broken teeth and cracks. When wear or missing teeth occur, you can also optionally diagnose planetary gear faults, such as planetary gear wear, missing teeth, cracks, or broken teeth. These are common failure modes. Now, let's connect the data acquisition equipment and sensors, and collect some data for demonstration. We've set up a 4-channel data acquisition system here. This is the data collector, and this is the host computer analysis software. First, we'll input the test project, name, and operating conditions. Once acquisition starts, it will display real-time time domain waveforms, and we can open multiple windows simultaneously. This will simultaneously display the time domain signals from 4 measurement points. Press stop once the testing duration is reached. At this point, the data will be saved in the directory. Then perform time domain and frequency domain analysis on the data. Meanwhile, the raw data can be exported. Common export formats include text, Excel, MATLAB, CSV, and other formats. All right, that concludes the overview. Thank you, everyone.
Yeah.